So we're going to discuss the cardiac action potential. Remember that this is occurring in the cardiac contractile cells. To begin with, what I want you to think about is where or what stimulated this cardiac action potential to occur. And so we're going to begin here at the resting membrane potential, which is near negative 90 millivolts. And so at negative 90 millivolts, I'm just going to draw a cardiac contractile cell. And remember that this cardiac contractile cell has gap junctions. Now, along with those gap junctions are your leak channels. And so the only leak channel I'm going to go ahead and put in is the potassium leak channel, because potassium is more permeable at rest, close to negative 90 millivolts, just as it is in a regular neuron. And we know that potassium moves out of the cell. So when this cell is stimulated and when a cardiac action potential occurs is because of a positive influx of ions from a neighboring cell. So we may have sodium or even calcium influx that causes this cell to respond. So this cell now is going to start the rapid depolarization phase, which is called phase 0. Because of a change in a membrane potential from an adjacent cardiac contractile cell through that gap junction, this now causes voltage-gated sodium channels to open. So we know that through voltage-gated sodium channels that we have sodium influx. Now these are very fast channels, which means sodium gushes into the cell. So with sodium gushing into the cell, the membrane potential becomes more positive. And this is the reason this is called rapid depolarization, and it occurs during phase 0. Now let's look at what will happen next. Phase 1 is a brief repolarization period. So when the peak of this action potential is reached, the voltage-gated sodium channels inactivate. However, now we have voltage-gated potassium channels that are open. And so potassium moves out of the cell. Since potassium carries a positive charge with it, then the membrane potential will repolarize just slightly. This is why this is called brief repolarization. The next phase is going to be the plateau. Now what we have are a new set of channels called voltage-gated L-type calcium channels. These are the same L-type channels like we had in the pacemaker. Through this L-type calcium channel, we will have calcium influx. During this period, we have positive charges coming into the cell, but we have positive charges going out of the cell as well via the voltage-gated potassium channels. So because we have positives going in and positives coming out, that's what will create this plateau. The next phase is phase 3, and this is repolarization. So in repolarization, the voltage-gated L-type calcium channels close. However, the voltage-gated potassium channels remain open. And so, because those remain open, you have potassium efflux, and hence the membrane will become more negative and it will repolarize. Just keep in mind that once you have a cardiac action potential, this can spread to an adjacent cardiac contractile cell via another gap junction.